The Earth is warming. Carbon dioxide is building up in the atmosphere, trapping solar energy and driving up global temperatures. But in the North Atlantic, that excess heat is triggering the exact conditions needed to cause a sudden, localized cooling event. We are looking at a projected cooling trend that could drop average temperatures by 5 degrees Fahrenheit across much of the United States and plunge the Northeast, Northern Europe, and Northern Asia by a full 10 degrees. This projected freeze is distinct from the brutal ice sheet that covered the Northern Hemisphere with deep glaciers 12,000 years ago. Instead, it is a smaller, highly intense regional freeze. The severity of this threat lies in the timeline. Oceanographers estimate the drop could happen within 10 years, and once the freeze sets in, it can take hundreds of years for the climate to reverse course. The physical catalyst for this sudden temperature drop is water. Over the past 30 years, immense rivers of fresh water have begun mixing into the highly salty seawater of the North Atlantic. The prime suspect for these fresh torrents is melting Arctic ice. As the atmosphere traps more heat, the ice caps melt faster, pouring fresh water directly into the ocean. The volume of this runoff is staggering. It's the equivalent of a 10-foot thick layer of fresh water spreading completely across the North Atlantic Ocean. Global warming is the direct mechanism driving the next ice age. The excess heat melts the ice, triggering a crisis of oceanic density. To understand how density controls climate, look at the path of the Gulf Stream. This massive ocean current acts as a conveyor belt, carrying dense, heat-soaked water from the tropics northward along the east coasts of the United States and Canada. As the current travels into the higher latitudes, the water releases its stored tropical heat into the surrounding North Atlantic air. Once that heat hits the air, the prevailing North Atlantic winds push it eastward, carrying a massive amount of the Gulf Stream's radiated warmth straight across the European continent. This chart shows the temperature disparity created by that wind pattern. Because of the Gulf Stream, winter temperatures in Europe are up to 36 degrees Fahrenheit warmer than those in North America at the exact same latitude. Boston is frigid, while Rome, sitting on almost the exact same parallel, stays relatively balmy. But the heat surrendered by the Gulf Stream also stabilizes winter temperatures for Americans and Canadians living along the eastern seaboard. This continuous loop of moving water and radiating heat, often called the Great Ocean Conveyor, is the mechanical regulator that keeps the entire northern hemisphere habitable. This regulator is powered by a process oceanographers call thermohaline circulation. The term relies on two critical variables, thermo for temperature and haline for salinity or salt content. When the warm water of the Gulf Stream gives up its heat to the cold northern air, its physical properties change. As the water cools, it condenses and becomes heavier. The ocean water is also packed with salt. As the cooling water contracts, it forces these salt particles closer together, drastically increasing the physical density of the water. Because this cold, salty water is now significantly denser than the water around it, it sinks. It creates an enormous underwater waterfall, plunging a mile or more to the ocean floor. That vertical plunge is the main engine. The immense weight of the sinking column pushes the deep water currents forward, forcing them to snake their way through all the world's oceans. Simultaneously, as that dense water drops out of the surface layer, it creates a vacuum at the top. This pulls more warm surface water from the south to take its place, creating a self-sustaining loop. If the water at the top cannot get dense enough to sink, the Great Ocean Conveyor loses its momentum, and the entire circulation system stops moving. When Arctic glaciers shed massive amounts of meltwater into the North Atlantic, they inject fresh water that lacks heavy salt molecules. It is physically less dense than the seawater. The presence of this fresh water is already registering in oceanographic data. In the Labrador Sea, researchers have recorded drops in salinity and temperature that represent the largest full-depth changes observed in the modern instrumental record. Because the fresh water is lighter, it sits on top of the ocean like a massive thermal blanket. Even as the Gulf Stream waters cool, this less dense fresh water cap prevents them from cascading downward. Without that sinking action at the northern end, the mechanical loop fails. The vacuum disappears, and the Gulf Stream is no longer pulled northward from the tropics. Pushed by a stalling engine, the Gulf Stream will slow down. The current may veer southward, failing to reach the high latitudes, or the circulation system could shut down entirely. There is increasing evidence that the ocean is nearing a transition point, a threshold where the system can jump rapidly from active circulation to a new, much colder state. The freshwater anomaly is a mechanical break on the planet's primary method for heat distribution. The National Academy of Sciences explored the fallout of such a shutdown in a 2002 report on abrupt climate change. They pegged the economic stakes from agricultural losses alone at between $100 billion and $250 billion. A slow climate change allows for adaptation, but an abrupt shift is like high water in a river. It poses few problems until the exact moment it breaches the levees, causing massive and immediate flooding. Biological systems undergo similar collapses when particular temperature and precipitation thresholds are breached. The report outlines a grim sampler of what follows: disappearing forests, dwindling freshwater supplies, lower crop yields, and accelerated rates of species extinction. During past cooling periods, entire tribes simply moved south to survive. Today, in a tense world of closed borders, that option no longer exists. The inability to migrate removes a major safety net for distressed populations. For people who live off the land, a sudden drop in regional temperature translates directly into rapid, inescapable changes in fortune. By trapping carbon dioxide and melting the Arctic, we are injecting a mechanical failure point into the ocean's currents. Global warming is the direct trigger for a rapid cooling threshold that modern civilization is currently unprepared to manage. This video is brought to you by the IELTS FOCUS, an English center specializing in IELTS preparation. Contact them on Zalo 0847 705 973.